All right, so we're going to go ahead and move on with our discussion into an example. So say we're walking in a direction A, so this is our vector, for 5 kilometers at an angle of 30 degrees. Okay, we want to know what the x component is of our vector here, A. Okay, so let me go ahead and draw this. That might help visualize it. So let me go over here. Oops, let me move this out of the way. Okay, so let me go ahead and draw this. So this will be my x and y coordinate system, and I will put my vector A here, and my angle here is theta, okay, and here is A. So I want to know my x component. So we looked at this in our last slide, in the last video, at the end, breaking down our components into x and y vectors, okay? So we want to know our x here, and so that would be a sub x, okay, on this x-axis. So let's see, we will need to use trigonometry in order to do that. So we know our magnitude of A is 5 kilometers. We also know our angle theta. Okay, so think about which trigonomic function we can use here. Okay, so it will be, we know the adjacent, or I'm sorry, we want to know the adjacent value, a sub x, okay, and we know our hypotenuse, so adjacent and hypotenuse, that gives us CAH. So we're going to say cosine theta is equal to adjacent over hypotenuse, okay? And so rearranging this formula using a bit of algebra, we know that the x component of A then is equal to A times cosine of theta, okay? So you can then put that into a calculator. We have 5 kilometers here times cosine of 30 degrees. Let me see where the calculator went. There it is. Okay. So 5 cosine 30 degrees, and we get 4.33 kilometers, or we can say 4.3 kilometers, around the same value, okay? All right, so that would be our x component of A. So if we wanted to know the y component of A, we would do something similar. So our a sub y would be right here, and we would say, okay, we want to know opposite, so then that's going to give us so that would be sine theta equals opposite, or a sub y over A. And we do the similar process to find a sub y. Okay? All right, let me go ahead and move on to, instead of solving these equations, or these equations graphically, we can also solve them algebraically. Okay, so say I have 2 vectors A and B that I'm trying to add together, okay, and that would result in our resultant vector R. Okay, so this we looked at graphically already. Now we can say, okay, let's break that down into its components. Okay, so what we know is that A, let me see if, okay, so A is AX plus AY, B is BX plus BY, okay, And these, we typically write down our unit vectors as well next to them. So I could say this is AX times I hat plus AY times J hat. Okay, same thing here, BX I hat plus BY J hat. Okay. And so when we are adding these things, we can take each component of these vectors and put them together in two resultant vectors. Okay, so this is called the component method. So now what we'll do is we'll say, okay, if we add these together, we're going to get R, right? And will result in some Rx times I hat plus Ry J hat. And so these are defined as so, okay? So this is just a way to add these things algebraically instead of graphically, okay? And with the more practice, it'll make a lot more sense and it'll become easier. Okay, so why don't we go ahead and do that? So in this example, we want to calculate the resultant components. Okay, so what does that mean? Resultant components means we want to know our X and our Y. Okay, we're still looking at 2D here. So we can go ahead and do that. We have our coordinate system here. We also have two angles here. We have theta and beta. Okay. And so our resultant vector is A plus B plus C. Okay. We also have our magnitudes listed down here. And we're not worrying too much about units right now. Okay. So let's go ahead and do this. So in the last one, we saw that our X and our Y will be the addition of each of these. So we have AX plus BX plus CX. Okay. Our Y will be AY plus BY plus CY. Okay. All right, so that would be 41. Oh, I'm sorry. Actually, let's go over here. We can't use these straight from these values. Okay, so what we need to do is first get our components. We need to find what AX is, BX, and CX, and same thing with AY, BY, and CY. So we need to get these components first, and then we can add these together. Okay, so let's look at this first one. Let's look at A. Okay, we want to figure out what AX is and AY. So this is AY, this would be AX. Okay, so we would use trig again. We want to know AX first, so I'm going to say adjacent over hypotenuse A, and that's what this value is. Okay, so adjacent over hypotenuse is going to be cosine theta. Okay, and then we can solve for AX as A cosine theta. So AX then is 41.0 times cosine of 29 degrees. Okay, and we'll do something similar for AY. We have opposite now, so that's going to be so sine theta is going to be equal to AY over A, so opposite over hypotenuse, and that gives us AY is equal to A sine theta, or 41.0 times sine of 29 degrees. Okay, and notice that I'm doing all of this, kind of planning it out, and then I will do the calculation in the end. Okay, So now I can go ahead and do that. So 41 times cosine of 29, I get 35.9 degrees. And 41 times sine of 29 degrees is 19.9. Okay. So now I have, I broke down my A vector. So I can do the same thing with B. Excuse me. So now we want to know what by and bx is. So I have adjacent, have the same idea here. So bx is going to equal b cosine 54 degrees. And b is 24.5. So 24.5 degrees. I'm sorry, not degrees. Cosine 54 degrees. There we go. So 24.5 cosine 54 degrees. That gives me 14.4. Oh, this is not in degrees. I'm sorry about that. I was very focused on degrees for some reason, but these, from the beginning of this problem, we don't have any we don't have any units. So these are unitless. Okay, so no units. Okay, so that's bx. Now by is going to be similar. B times, this would be opposite, so it's going to be sine of beta. So 24.5 cosine, or I'm sorry, sine of 54 degrees gives me 19.8. Okay. Now C is going to be quite a little easier because C is just pointed in the y direction. There's no x component. So Cx is actually 0. And we only have C sub y. And if all of our magnitude is in one direction, then the magnitude listed here is going to be the same. So this is going to be 31. Okay. All right, so now what you can do is you plug in all of these numbers, and I know it's kind of all over the place, but I can go ahead and do that on my calculator. So for r sub x, we have a sub x here. So we have 35.9 plus, oops, that did not mean to be crossed out, b sub x, which is 14.4, and then c sub x we determined is 0. So we get 50.3 is our resulting component in the x direction. Then for y, we have 19.9 plus 19.8 plus 31. So our r sub y component is 70.7. Okay. Now I know that there's a lot on this screen right now, but hopefully that made some sense. And this is just the first part. So I'm going to go ahead and erase this and then go into the next video with the second part. Okay, so we have our r sub x and r sub y. Now we will need to calculate our magnitude and direction of that resultant. Okay?